Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, I'm Hannes. I'm a principal consultant working for Axxes in Belgium, and I'm joined here today by Eli Holderness to talk about responsibly using GP records for research purposes. Eli, would you care to introduce yourselves to the audience?
Hello, yes, my name is Eli. I am a research software advocate at the Bennett Institute based out of the University of Oxford. And the main thing that the Bennett Institute does is produce, administer, build, design OpenSAFELY, which is what I'm going to talk about with Hannes today.
Now, just for the reference of the audience, can you maybe explain a little bit what OpenSAFELY is, what it does, so that we have a little bit of an idea what we're talking about?
So the way I like to talk about it is that OpenSAFELY is both a philosophy of research, sort of data science being used for research purposes, and it's also a set of tooling that enables that philosophy to be carried out. The idea is that if you've got lots of sensitive data, so at the moment we have access to about 58 million rows of patient data in the UK provided by the Royal College of GPs. If you want to use that data to draw insights about, public health, you want to make sure that that data is handled responsibly with respect to patients' privacy and that the tooling is in place to make that easy. And at the moment, what we have is, we have access to about 58 million rows of patient data, and it's up and running. Papers are being written based off the back of research done using the OpenSAFELY tooling. That's what it is. But the philosophy of it is the idea that if you've got this patient data, if you've got sensitive data and you want to run code against it, you want to query it, you want to do statistical analyses, either you have to move that data out of whatever secure environment it's stored in, or you have to take the analysis to the data. And so that's what OpenSAFELY does, is all of the research code that is ever run against this data that we have access to happens behind a sort of secure environment.
That's really interesting to me, because the way I just understand what you just said is instead of giving people access to the data so that they can query it themselves and draw their own conclusions, you are going to be operating their code against the data, and they never see the actual data. They only see the results of their analysis. Is that how it works?
Yeah, pretty much. So if you are a researcher and you want to write a study and you want to use OpenSAFELY to do it, you contact us, you get approval for your study. So there's several governing bodies that we need to go and talk to about that. NHS England is one of them. We have our own approvals process, sort of pre-approvals process. Once you have been cleared to run that project, you get put in touch with one of our co-pilots or our co-pilot team, which are a sort of first line research support. You write some code publicly on GitHub. You don't have to make the repository public until you've actually published any papers, but you write code on GitHub, and the way that code ends up being run against the real data is that you submit it to us through our OpenSAFELY jobs server. You schedule a job, and then we take that code, which is some of which will be written in our domain-specific query language, which we wrote specifically for working with electronic healthcare records, it's incredibly cool, and it is open source, and I will love to talk more about it. You write code in that query language that is then eventually compiled to SQL that runs against the specific database that we have access to, the secure backend. And all of the code that makes that happen is open source as well. So our job site, our job runner, all of these things. That code then runs in the secure environment. And we, as the OpenSAFELY team, have access to certain things within that that secure environment. So we've got some limited telemetry that we can get out of there. We can know why jobs failed or if they succeeded, things like that. But we don't even have direct access to look at that data. It's super locked down. So your code has run, you've extracted data from the database into sort of working memory essentially there, and run transformations on it. You've run your analyses, any statistical models. And then the results of that are aggregated and made available to output checkers. And output checkers are trained professionals, usually researchers themselves, who look through the results of what you've done, which might be like tables and graphs and things like that, and check whether any of what you've output is disclosive, could be used to identify individuals or small groups of individuals.
Right.
And that's like, there are absolutely hard and fast rules about how that's done, but there's also some element of judgment calls about whether or not, well, it's okay that this number was referred to only a really small number of patients because we expected that as part of the study design. So that's a key part of the process. Mm-hmm. And that's something that's standard across any kind of research that deals with sensitive data is output checking.
I mean, you can even see it in systems where you are trying to measure employee satisfaction. It's a place where I've run across this. If you start adding parameters to your queries, as soon as you would get close enough to being able to identify one of your employees, like who has said this one thing.
Yeah, you have to shut that down.
You have to shut that down. And basically that's what you have to do for records that are way more sensitive than employee satisfaction.
Right, like as far as I know, my data is in that back end. So with GP records in the UK, there are two main suppliers of electronic healthcare records software. Mm-hmm. And they are TPP and EMIS. And in the past, OpenSAFELY has had software running in both of those backends, secure backends. At the moment, we only have TPP for funding reasons. And I don't know which one of those two my GP record data is in about me. But if I wanted to, I could go, well, I know that I had an appointment on this time at this date and I was diagnosed with this or I was prescribed this or whatever. And I could potentially use that information that I have about myself to explore my own records, remotely. But the thing is that I would never get that information back out because the output checkers would go, well, that's not good. You can't be doing that, because I could do it about myself, and maybe you could argue that I should be able to do that about myself. I shouldn't be able to do it about, let's say, a politician in my country some of whose medical history is known. So output checking is a sort of key part of how we preserve privacy of this data.
And that at the moment is still done by humans?
Yes, it's still done at the moment at time of recording by humans within the Bennett Institute. That doesn't scale infinitely. So we're looking at better ways to have that output checking be performed by a broader set of people. Obviously, having people outside the Bennett Institute do it as well reduces the chance that anybody could think that there's bias. Because obviously we're doing science here, so we want it to be as open and as sort of democratic as possible.
You base these studies off of the general GP data that's in that database. Mm-hmm. What kind of research are we looking at here? What's the type of studies that are being performed against this?
So at the moment, OpenSAFELY started during early days of COVID. And at the moment, what we have is we have permissions for any studies to be run that refer to that are related to COVID. So we have studies about things like rates of certain drug prescriptions during COVID, rates of incidence of certain diseases, linked secondary conditions. Obviously, we've got one of the primary arguments for having this data available for research in the first place during COVID was, do the vaccines work? Who's getting them? Do we see side effects? So lots of things like that. As we move away from the period in time when that stuff was considered most critical, we're looking at time of recording, we don't have permissions for non-COVID related research proposals to be granted with OpenSAFELY, but work is being done to make that happen. So ideally, maybe sometime this year, maybe sometime next year. I'm not qualified to say definitively, but we'll have permissions for any kind of research that you think, any question you can ask that you think might be answered with this kind of data. But it's interesting because this data it's not clinical research data. It's data that has been collected for the purpose of GPs being able to do their jobs and provide primary healthcare. So
does that mean that maybe there is some data lacking in the system, or some data that is not really structured for things that these researchers are doing with it?
Well, one of the interesting things, so we have access to this GP data. There are also linked data sets, so like a renal registry data set and sort of specialist things like that. And all of these data sets have different formats and different ways of accessing them, which means that when you as a researcher write code against some of this data, if you're doing it directly in the model that is not the OpenSAFELY model, the standard model where you are sort of given direct access to a pseudonymized curated data set, your code is very bespoke and can only run on that database and that data set, essentially, because the schemas are wrong.
Yeah.
And so what OpenSAFELY has done is try and solve some of that problem of, because it's all these disparate sort of schema and things like that. Schemata, sorry. We've written this domain-specific query language that will compile to the right kind of SQL and the right kind of things.
What are some of the intricacies of this DSL that you created?
So it's built on top of Python, and which is just a choice we've made because it was the research language. I mean, obviously you have Python, you have R, and you have Stata as some of the three of the most commonly written languages for doing statistical research. And Python, out of those three, was the one that the tech team were most familiar with because it's also a software industry language in a way that sort of R and Stata are much more specialized into their research domains. What it is it looks very much like Python with some sort of weird bits of magic sprinkled in, sort of messing around with Python internals and things to make certain things work. It's really, really cool. And the language is Electronic Healthcare Record Query Language, EHRQL, URQL. URQL to rhyme with circle. Mm-hmm. And what you do as a researcher is you write this code, and it looks very much like Python. And then what happens is that is sort of serialized into a query model. And then that query model is then analyzed to create eventually a SQL query. And what kind of database it is running against is part of the configuration. So for TPP, I believe it's a MySQL database. And so the version of URQL that runs when you submit code to run against that database is going, I want to output MySQL SQL. But let's say another data provider might have Postgres, and if there was a version of OpenSAFELY running there, it would spit out different SQL. But the idea is that you can write a query once and then run it in a variety of different environments and get back with the results you expect.
So you could theoretically in the future run the same programs that your researchers have written against different healthcare providers.
Exactly.
Or possibly even different countries, or is that completely out of scope?
Who can say? I mean, I know that there are the research, that one of the reasons that I like to delineate OpenSAFELY into a philosophy of research and also this tooling is that philosophy of research, that you write hypothesis-driven code and then you submit it to be run, and then you get back some aggregated output-checked results. That is not by any means specific to healthcare. You could do OpenSAFELY pensions to analyze how people's pension investments happen and which groups are more likely to choose pensions that have this characteristic or whatever. And that's also sensitive data. You could do, OpenSAFELY, we have an initiative called OpenSAFELY Schools, which is about using that research philosophy to investigate education data, which is another domain where there's sort of very fragmented, bespoke data sets in all sorts of places across the country. The tooling to enable it might change because it doesn't necessarily make sense to have something that's very specialized towards electronic healthcare records being used to analyze pension data. There is absolutely huge potential for this model to be used across different domains. One of the big challenges is that if you are committed to data not leaving the center in which it is held, how do you do linkage across different data sets?
Right.
Yeah, which is not something that I know much about, but it's a common problem across sort of all sorts of sensitive data research. And the trusted research environments, which are the other model that OpenSAFELY is OpenSAFELY is referred to sometimes as a TRE, but it operates in a slightly different way. Whereas most trusted research environments, you as a researcher, once you're given approval to have access to the data, you are given access to a curated, pseudonymized. But one thing about that is that who curated that data, who pseudonymized it, it's not raw. There is already, in a very technical term, bias introduced into what you as a researcher are allowed to access, because there has to be in order for you to be able to view it directly. But if you don't have to view it directly, you don't have to pseudonymize it or curate it first.
Stay with us. We'll be right back.
Should I be excited or afraid of AI? The answer is yes. It's both.
Things are going to look so different in the next couple years. You will not be ready for the disruptions that are going to come. I'm Jeff Nielsen, host of Digital Disruption, the go-to podcast for technology leaders.
Our generation's conflict, I think, is going to be emotional, not economic.
The companies that are going to win are the ones that have a couple of characteristics.
Stay ahead of the curve with Digital Disruption, available now on your favorite podcast platform.
Right.
Yeah.
Does this whole process impact the way that research is performed? Because since you don't get access to the source data, I can imagine that as a researcher, you have to adjust your approach. You cannot just go and click around and explore what you have.
Yeah, there is definitely a sort of culture shock almost aspect to it where researchers will learn, like they'll sort of get started with OpenSAFELY, and it is a very different experience. They can't sort of run exploratory queries and get results back in a very fast feedback loop. And that is a trade-off. Like, it is in some regards less usable, but it does also prevent you as a researcher from doing what's known as p-hacking, which is I have a hypothesis and the data doesn't quite support it, but maybe if I exclude like that group of people and make up a justification as to why I should exclude them, and maybe exclude that group of people and maybe only take results from that, I can, suddenly now I have managed to massage the data into supporting my hypothesis. You can't do that with OpenSAFELY because the feedback loops are longer. I mean, you could in theory, it would just take forever. And also because the code that you write, if you ever publish a paper using OpenSAFELY, like off the back of research you did using OpenSAFELY, we require that you make your code public as well. And anybody could really look at that and go, why did you exclude those groups? Why did you exclude? Right. What's your scientific basis for doing that? And it made my hypothesis correct is not a scientific basis. So it enforces you as a researcher to take a hypothesis-driven approach where you have to clearly upfront state, what are you doing? What do you expect to see from it? And you get the results back. You can't fiddle with things in quite the same way.
Basically forces people to think about their hypothesis a lot harder.
Well, I mean, I like to imagine that researchers are all thinking about their hypotheses really hard. So something that this sort of touches on is that research as a profession is a really difficult thing because as a researcher, you want to do good science. And people have got into doing research. Nobody goes into like doing epidemiology because they just,
want to get paid.
Exactly. Well, maybe there are some, I don't know.
Paid,
but as a researcher, you want to do good science. You don't want to be doing things where you're like, I need to massage the data to prove, to retrofit my hypothesis. But if you don't have positive results to publish a paper, your university is going to drop you. Like you need to also have a career in order to keep paying the bills. But maybe you just don't, maybe you're asking questions and you're proving things that are really useful. Like there is no link between this COVID vaccine and increased rates of pneumonia or something. Pulled that one off the top of my head. That's useful to know, but it's not the kind of thing that's easy to publish and get, acclaim for industry sort of professional status for. And so as a researcher, you're caught between this rock and the hard place of, well, I need results in order to continue having a career and continue to have like maybe tenure somewhere versus the results just aren't my hypotheses just aren't bearing out. And so I guess OpenSAFELY is tilting the scales more towards you actually have to ask the right question up front. Yeah. So that's another interesting aspect of it.
You mentioned that the code is written in your DSL and then you execute it. How does that work compute-wise? Like which servers does that run on? Who manages all that infrastructure? Who is funding that? So when you as a researcher write code, URL code, you can test it locally. And we have dummy data generation that happens when you run code locally. You can also curate your own dummy data set and just plug that in if you want. And so when that happens, all that is executing locally and in the exact same way as it does in our backend, actually, which is a design decision that the team made very intentionally because they wanted to have, if you have an error in the backend, we want that to be something that you could have caught locally because otherwise that's a lot of time that you've wasted. So when you run things locally, it's all local and you're never touching sensitive data. It's just not part of it. That's fine. Privacy wise, infrastructure wise. We quite heavily use code spaces for our researchers as well. So we encourage people to work in a code space and then it's, GitHub's resources, essentially. When it runs in the real world, in the secure backend, it is all operating within, at the moment, TPP's database servers. So we have a little VM in there and we've got all of our tooling in there that is required. So we've got a piece of tooling that schedules jobs, schedules like workloads, and then the actual executable code. So what happens when that is executed is it essentially eventually gets compiled to, the SQL that runs against the database in question with a few sort of firewalls in the way of there's sort of various points where like at some point it's compiled to JSON and then recompiled. And part of the reason to do that is because
You can sort of verify that certain properties of the SQL query are correct, are true. You're not going to return anything with that's sort of a too low a value, or that's one of the things about discursivity is if this query only returns one patient, you probably shouldn't let people get hold of that and things like that. And so there's various points in that execution stage where we have quite a good control over the ways that code behaves. However,
are those things that you check automatically? Like, hey, there's a query that's running here that's returning very little data?
Good question. I don't actually know. That would be a question for the platform team that build and maintain Urkel, which I'm sort of embedded within at the moment. But what you can do is you can go and look at the source code because it is all open source and figure it out. And that's what I might go and do after this interview because I'm interested in the answer too.
Because that seems like one of the easy ways that you can already introduce some machine-based
just low-hanging fruit. Yeah. And there is discussion within this sort of community of secure records research about the idea of using some kinds of machine learning or some kind of automated output checking, not to completely remove humans from the process because there'll always need to be some human eyeball. I think there'll always need to be human eyeballs in there at some point, but to reduce the load on them and to make their job easier and to just sort of clear out some of those low-hanging fruit type issues.
There's always going to be humans involved, as you mentioned, because the data is very sensitive. But another thing you mentioned about the data is that it's not really collected for the purpose that it's being used for at the moment, right?
Yes.
It's collected by GPs to have patient records, but now we're using it for statistical research.
Yes.
What are the difficulties with that? Because I'm assuming that there's maybe some stuff missing here or there or something else going wrong.
Yeah, so one thing that comes to mind is, so medications and diagnoses of conditions all have codes. So for diagnoses of conditions, that's usually a SNOMED code. There's also a DM&D code format that is used for some medications. And there are some of these, they're all sort of arranged in these hierarchies of, so there's like asthma codes and they all sort of come under a category and then you have more specialized ones under, further and further. And like for medications, it's like, well, here's the entire class of things that have got paracetamol in. And some of these codes, GPs just don't ever use, or they might put in a more general kind of code they might say, look, well, I prescribed this patient ibuprofen, but actually what they went and got from the pharmacy was this very specific type of Nurofen with this many pills in the package. And if you're a researcher who wants to know about that specific Nurofen with this many pills in the package, but what was coded was ibuprofen, you're not going to be able to know that. But for GP purposes, that's fine. So that's an example of where if researchers got to specify what data was collected, they'd probably want things to be very, very granular. But that's complicated for a GP to do. It's not what their primary job is. So it doesn't happen.
Right. So if you want to clean that up or make sure that the data is more complete, you would have to have all the GPs participate in.
You would have to make it easy and worthwhile for them to do so.
All right.
Yeah. And at the moment, there's not an incentive because that's not what the data is for. And nor necessarily should it be, right? You don't want to make GPs' lives even harder than they already are because they could use more funding, could use more support, as always. You don't want to make their lives harder than they already are for the purposes of clinical research, even though clinical research is vital and worth promoting. If it means that GPs are less able to do their jobs, we can't make that trade-off.
Right. What to you are the biggest risks of this type of research? So assume that this becomes really popular. Like where might we have to intervene?
So one thing that we haven't talked about yet is the fact that this data, it is owned and managed by GPs, but it belongs to patients. And the GPs have a duty to respect the patient's wishes, desires for privacy, for safe usage, for worthwhile usage of their data. And if something that we do, whether that's the Bennett Institute, the research community as a whole, the College of GPs, if something happens such that patients' trust there is eroded or damaged, that's really bad. So in the UK, you can opt out of your GP records being used for research purposes, called type 1 opt-outs. And I think there's about 3 million people, maybe, who have opted out of their data being used for these research purposes.
And
if that number rises...
You still have the data, But you can't use it, or
Good
the data is
question.
not in the system?
Good question. That is a question for TPP and EMIS. And I don't know the answer, but I know that you should not be using that data for research purposes. I think that data still has to be in their database because GPs still need to access it. It just won't be made available to us, or there will be some flag on it that says we can't use it, is my understanding. But if that number of people who have chosen not to allow their data to be used, if that rises because people don't trust that it's being used responsibly, we can't do science anymore. Like if everybody opts out, we can't do science with it anymore.
Yeah, you'll devaluate the data set.
Exactly. So we have to be extremely careful and conscientious of that. And we do have a team at the Bennett Institute, PPIE, Patient and Public Involvement and Engagement, to make it easy for people to come to us with concerns or questions and have those addressed or be put in touch with the right person who can address them. So that's one failure mode that could be very, very bad, is that if people feel that their data is not being respected and handled with the appropriate care and privacy and sort of, used for good purposes. And this is part of what the approvals process for studies is about making sure that people are not using GPs and patients' data in a way that could be harmful to them, isn't actually a public good, things of that nature. But a failure in that process could be really, really bad.
Okay, let's maybe, as a closing to this interview, where do you hope all of this would go in the future? Where do you see the biggest benefits?
So we talked about applying this philosophy to different domains. And to me, that kind of is the dream, is that where we have sensitive data, we have something like this in place to allow it to be safely used for research. And I know that's something that, the Bennett professor at Oxford is Ben Goldacre, who wrote Bad Science and Bad Pharma. And so he's my boss, a couple of levels away from being my boss. And I know that he has often talked about the idea that maybe this could be the future of secure records research in lots of different domains. And I think that that's the dream, kind of, is that this philosophy and, set of toolings, which doesn't all have to be built by people at the Bennett Institute, right? Could be the standard way of doing research with secure records that, it makes it easier to do better science, more reproducible science. That to me is kind of the dream. And then we use it to solve all the problems in the world forever, right? Because we can just do that with more data and asking the right questions, I believe.
At least it will have a positive impact.
Yeah, and it's really nice to go to work every day. I mean, go downstairs and work remotely, but feel like my job is doing something to make the world just a little bit better. That's a rare thing, and I really appreciate it.
Thanks so much for joining me today, and thanks for giving us an insight in what it is that you do. Yeah, responsibly handling records and patient-sensitive data. I at least feel reassured that my data isn't used in a way that it wasn't intended to be used as. So thank you so much.
Always a pleasure.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.